Following on from the previous video, we got to this stage here. We got to this stage. We got to this stage here. So what we were doing was that we were trying to show that it's monotonic. So we got this divided by this. So for the next term divided by the current term, if this thing here is less than 1, then we know it's mono. Well, we know if it's less than 1, it's going to be always be decreasing. So we would get, so this is your an plus 1 divided by your an, and then this thing here we would tidy up to this, and then now we got to this stage here. So in the previous video we got to this stage here. So now let's try and tidy this up. So if you look at this here and this, here you've got n plus 1, here you've got n. So you can imagine, so when you look at this and this, you can imagine this as being 2 times 2 times 2 times 2 times 2, for example, and then divided by, well, this is 1 notch lower than this n plus 1. So this will be 2 times 2 times 2 times 2, and there will be nothing here. So now these will cancel out, giving you 2. So this and this combined together will give you just this 2 here. And then if you look at this here, n factorial and then n plus 1 factorial. So if you look at this, you can imagine this as being 4 times 3 times 2 times 1. So you can imagine n factorial is there. Now this is 1 notch higher. So n plus 1 will be 5 and then factorial times 4 times 3 times 2 times 1. So these will cancel out, leaving you with 1 over 5. So leaving you with in this case here, leaving you with n plus 1. So this thing here we simplify to this. So now remember what we've done here is we got an, we got the next term divided by the current term. If this thing here is less than or equal to 1, then we know it's monotonic. So in this case, if you look at this here, so don't forget when we did this, it gave us this thing here. So now if you look at this here, this thing here is actually always less than or equal to 1, meaning it must be monotonic. Because if you look at this, remember when it comes to sequences, n can only be positive integers. So as you increase n, let's say n starts at 1, so 2 divided by 2, that's 1. And then increase n, so the next term will be 1, so 2 divided by, hang on, the next term will be a 2 here, so it will be 2 over 3 and so on. The point is that n is always positive and it starts from 1 all the way to infinity. So this thing here will always be less than or equal to 1, meaning that our sequence is monotonic, meaning that it's always going downhill. It's always going downhill. So we were trying to show that this sequence converges. We now know for sure that it's monotonic because an plus 1 divided by an is less. Well, we show that it's less than or equal to 1. So we know for sure that this sequence is monotonic. Now we need to show that it's bounded. Remember, if we can show that it's bounded and it's monotonic, if we can show these two, then there's a theorem that says that this sequence must converge. We've shown that it's monotonic. Now to show that it's bounded. Well, here this is monotonically decreasing. It's always decreasing. So we don't need to care about the upper bound. We only need to care about the lower bound because it's always decreasing. We don't care what happens with the bound, with the upper bound here. We only care about the lower bound because it's monotonic, decreasing. It's decreasing. So we only care about it being bounded from the bottom. So if you look at this here, this thing here is actually bounded from the bottom because remember, when it comes to sequences, n can only be positive integers. So if you look at this here, 2. So if you look at n here, 2 times 2 times 2 times 2, and this thing here, n factorial. Let's say 1, 2 times 2, 3 times 4 times 5 and so on. This thing here can only be well, it can never be a negative number. If you look at this here, if you look at this, this divided by this can never be a negative number, because this thing here, you've got 2 times 2 times 2 times 2. Remember, when it comes to sequences, n can only be positive integers. So for sure that this thing here cannot be negative. For sure that this thing here cannot be negative. So we know that, well, we don't know where the bottom boundary is, but we know that it cannot be a negative. So let's just say the lower bound is 0. Let's just say the lower bound is 0. It could be somewhere up here. It could be 0.00723. It could be bounded at this point, but who cares? Let's just say it's bounded at 0, because we know that this cannot be negative, this cannot be negative. So let's just say the lower bound is dead on 0. Let's just say that. And we know that it's monotonically decreasing. So therefore, there's a theorem that says if it's monotonically decreasing and it's bounded from the bottom, so that there will come a point where it will just converge. So this thing here will converge. Okay, just because we know it's monotonically decreasing and we know it's bounded from 0. So this thing here must converge. Okay.